All right, so there's a whole bunch of quadratic equations that we're going to be solving. We're going to try to solve them all the different ways with factoring, completing the square, square root property. Probably not going to do a lot with the quadratic formula, just on the fact that I'm not a fan. Because there's other ways to do things that are more efficient. I prefer not to use the calculator and programs to solve things. So, but we'll just see how we go. Some of these things, they're easier to solve because I've done a whole bunch of these and you start to see the numbers. So as your number sense improves, you'll have more options for how you see things. So this problem right here, the first one, the S, we have 4k squared minus 1 equals 63. All right, anytime that I have an exponent of 2 or any other exponent, that will tell me the number of answers that I should be looking for. They might be the same, so at most I will have 2 answers. They could be 2 completely separate answers, they could be 2 imaginary answers, or they could be the same point. So it's either 2 answers, 1 answer, which it would be the same, or no answers, which just means they're imaginary. So, but looking at this, I see that this is 63. I see a squared, and I'm thinking my perfect squares. And I know I could get this to be 64 pretty easy. And then I see the 4, and that goes into 64. So that's what my gut instinct is going to tell me to do. I'm going to add 1 to both sides. And this isn't the only way to solve it. We can use any of the methods to get the variable by itself. However, this is what I see currently. So I have 4k squared equals 64. I want to get that square, the k by itself. So I am going to divide both sides by 4. So now I have k squared equals 16. All right, this is a nice one. I have a perfect square, 16. I can square root both sides. And just remember, when I square root, I have to remember that plus or minus. I could also get this equal to 0 and factor it because it's going to be a difference of 2 perfect squares. But I have k equals plus or minus. The square root of 16 is 4. Those will be my 2 answers for this. So I'm not going to worry about the puzzle in the bottom. I'm just going to be solving these equations, and then we're going to see where we go from there. All right, so this second one, the M, I'm just going to work across. I've got it set up kind of to do the difference of squares, not the difference of squares, excuse me, completing the square, because I've got all of my letters here. I've got my number there. I think I'm going to do the completing the square because I'm going to end up with a fraction, so it might cause you guys to like not be so happy with it. I could also factor this one if I got it equal to 0, but I'm going to complete the square just because I can. All right, so remember, if I'm completing the square, I have the v squared plus 9v. I'm going to leave some space, and then I have my minus 14. I need to take half of this, half of the 9, and square it. All right, so this is going to be plus 9 halves squared. And then when I add it to this side, whatever I add to this side, I have to add to this side. So this is going to be plus 81 over 4. So that doesn't look so great because I have to deal with the fractions, but I can deal with the fractions. So this side is just going to be v plus 9 halves squared, because that is the way that we have a perfect square trinomial. The middle term is, the square root of the ends. And then this is, I need a common denominator. So this needs to get multiplied by 4. 4 times 14 is 56. So negative 56 over 4 plus 81 over 4. Those can be combined. So I have v plus 9 halves. I know, it's a fraction. We love it. Equals 81 minus 56. 81, 56 is 25. So it kind of works out nice anyways. I like 25. I now square root both sides. Square root plus or minus. So I have v plus 9/2 equals plus or minus 5. And then I can subtract the 9/2. So v, let's change color. V equals negative 9/2 plus or minus 5. And I could say that this is 5 over 1, which would be 10/2, but I'm just going to leave it as, well, yeah, I'll leave it as 5. Because I can have fractions and whole numbers. I should actually get those numbers, but I'm going to wait until I get to the choices. Actually, no, I'm not. I'm going to say that 5 is 10 over 2. So this is 10 over 2. So negative 9 plus 10 over 2 is going to equal 1/2. And negative 9 minus 10 over 2 is 19/2, negative 19/2. Okay. So the next one, I don't know what I want to do with that. So this one I'm looking at, I'm going to put it in, I'm going to get it in standard form. So I'm going to get a 0 for this one. So I like the x squareds to be positive. So I'm going to add 2 to both sides, and I'm going to subtract 17x, and I'm going to do that on both sides. So minus 17x. Right. And plus 2. So what I really have to work with is 8x squared minus 17x plus 2 equals 0. Now, the sign of this one will factor, because I can multiply 8 and 2, which is 16, times 2 is 16. And if I write my factors of 16, it's 1 and 16, 2 and 8, 4 and 4. I need to move that over. I should have changed color, but I didn't. I could do that now if I really wanted to. This, make pink, theoretically. There we go. This, I want to move over. And this, the other factor is 4 and 4. So this color, and I will make it pink. Okay. So because this is positive, I know that I'm going to add they're going to be the same sign. So I'm going to add my factors. I need to get a negative 17. So it will be a negative 1 and a negative 6. So this, I can rewrite it in four terms. So this is 8x squared minus 1x minus 16x plus 2 equals 0. This is one way to factor. It's basically unfoiling. And then I'm going to do 2 at a time. And 2 at a time. These two I can pull out an x. So it's going to be x times 8x minus 1. This I can pull out a negative 2 because I want to always pull out whatever the sign is of the first one. And this is minus 2. And then I have 8x minus 1 still equals 0. And then I will make it x minus 2. The stuff in the parentheses matches. So that's my GCF. And this is 8x minus 1 equals 0. Solving each of these, I know this is going to be a long problem. I probably should have done this on another piece of paper. So x minus 2 equals 0 and 8x minus 1 equals 0. My final answers are going to be 2 and 1/8. Okay. When I think about it. All right, put that in set notation. And then this one, I can easily, it's nice and quick. It's already set up for completing the square. This would be x squared plus 4x plus half of this squared. Half of 4 is 2. So 2 squared equals, I can write, equals 12. And then I have what I added here, I have to add here, so plus 4. So this becomes x plus 2 squared equals 16. Then I square root both sides, square root plus or minus. I have x plus 2 equals plus or minus 4. And then we have x equals negative 2 plus or minus 4. So x equals negative 2 minus 4 is negative 6. Negative 2 plus 4 is 2. So those are my answers. And we could have write it out a little bit more. However, I'm trying to squeeze in these little teeny tiny boxes. All right, looking at the next one, I see 1a squared that I'm dealing with. I probably would deal with that one similar to the one I did above, where I'm trying to get it all by itself. I don't see any other a's, so that's where I can use that square root property if it works out nice. So I am going to move everything away from that a squared. So I'm going to add 1. And now I have negative 3a squared equals negative 3. Divide both sides by negative 3. And I have a squared equals 1. I can either get it by itself and get a 0 on one side and factor it, or I can square root both sides, which is what I'm going to do. Square root, remember, plus or minus. And then I have a equals plus or minus the square root of 1 is 1, and that one is done. All right, yet again, I'm looking at what I have set up. This has got all of my a's on one side, plain old numbers on the other side. That actually tells me that completing the square is the best option for me. So I'm going to rewrite a squared minus 6a equals negative 8. And then just so that it's a little clearer, because I figure I've been doing this kind of fast, I am going to do half of 6, which is 3. So I'm going to be adding 3 squared to both sides. 3 squared is 9. So my problem really is this factors because it's in that perfect square trinomial form. This is a plus 3. And if you're really doubting with that perfect square trinomial, I do recommend you taking quite a few of these binomials, squaring them out and seeing how that middle term affects and changes, and it becomes twice the square root of the endpoint. So it does help. And negative 8 plus 9 is 1. So this is all set up for what we want. We can square root both sides because I have only something squared by itself. Can use that square root property. So I have a plus 3 equals plus or minus 1. Still have to finish this. So I have a equals negative 3 plus or minus 1. Negative 3 plus 1 is negative 2. So I have, and negative 3 minus 1 is negative 4. So those are my answers. All right, this one, I only have K's. I cannot divide both sides by one of the letters because I will lose answers. So don't ever do that. For this one, I would probably get them together on one side. I can't just square root, it wouldn't fix anything. So I'm going to add the 2k to both sides. And then I have k squared plus 2k equals 0. Easiest way to solve this one is I don't have any plain old numbers. I can factor out a k from both of these. So this becomes k. I'm pulling it out, so it's going to look like a distributing problem. And k plus 2 equals 0. From here, I can set each one equal to 0. So k equals 0. K plus 2 equals 0. My answers are going to be 0. And if I subtract 2 from both sides, k is going to equal -2. And that will be my answers for that one. All right, looking at the next one. I have things kind of in weird order. If I get the r's together, that's the first thing I want to do. I want to get that 12 over here. I could factor it if I think of my factors of 32. I could also complete the square. I've been doing a lot of completing the square, so I'm going to factor this one. Meaning I'm going to get this to equal 0, so minus 12r minus 12r. I want it in standard form, so I want that in the middle. So I have r squared minus 12r plus 32 equals 0. I need my factors of 32, which is 1, 32, 2, and 16. 3 doesn't go in there, 4 and 8. 5 doesn't go in there, 6 doesn't go in there, and 7 doesn't go in there, and now I'm back to 8. So those are all my factors. I need them to, because this is a plus, they have to add or subtract, they have to be the same sign, and I have to get to a -12. So I'm going to have a -4 and a -8. If I because this is starting with an r squared, I could rewrite it to the 4 terms, or I can just automatically know that it's going to be an r and an r, and then I'm going to put these in the back. -4 minus 8 equals 0. And then when I solve them, basically I'm setting each one equal to 0. So r minus 4 equals 0. R minus 8 equals 0. That is not a good minus. So r equals 4. R equals 8. So my answers are 4 and 8. Okay, so this is just a lot of practice of just what we've been working with. All right, and some of it is you get a feel for it by looking at the numbers that you have. It gets better. Now this one, first thing I do is I see I have like terms that I want to get together. So I'm going to subtract the 6 from both sides. And I have x minus x squared minus 3x equals 0. This is a nice one that hopefully you recognize that you can factor out that x, just like we did on an earlier one, where this becomes x times x minus 3. And now you can solve each one of those. X equals 0, x minus 3 equals 0. So your answers are going to be the 0 and 3. Cool. And I don't need to box it. I haven't been boxing anything else. All right. Now this one, I don't like. It's got a lot more going on here. This is probably the one case that I would probably do the quadratic formula because the numbers aren't that great. So the first thing I would do is add the 42 both sides because I need to get a 0. So 5p squared minus 37p plus 42 equals 0. This is just all sorts of not nice numbers. I think it's going to factor. We're going to test to see if it factors because I'm not looking for, with the quadratic formula, it is that b squared. If I'm looking at that, I'm going to be squaring 37, and that just doesn't look like fun to me. So I'm going to try to hope that it factors. And we're going to show you how you test to see if something factors, whether or not it does. So it's the first times the last. So 5 times 42 is 100, no, 20, and 5 times 40 is 200. 5 times 10 is 10, so 210. So I need the factors of 210. It's 1 and 210, 2 and 105. 3 goes in there because they add up to it, and 3 times 7, so this is 3 and 70. 4 doesn't go in there because 2 is not with an even number. So I know no more even numbers are going to go in there. Well, no more just powers of 2. So 4 doesn't go in there. 5 does because it was 5 times 42. 6 does because 3 and 70. This is even, so 6 and 35. 7 did because 7 goes into 21, so 7 times 30. 8 doesn't because 4 didn't. 9 doesn't because if I add up those digits, it doesn't equal 9. 10 does, 10 and 21. 11 does not because I can't take the two end numbers and get that middle number. 12 does not because 4 didn't. 13, no. 14, yes. 2 and 7. So it's going to be 14 and 15. And that will be all of them because I'm going to go back to where I have. Now, this is the plus sign, meaning I have to add them to get that 37. So it's actually going to be this one right here. So I'm going to rewrite. I have 5p squared minus 7p minus 30p, sorry. And then plus 42. All right, factoring 2 at a time. These two, we can pull out a p. These two, we can pull out a -6. All right, so we have p times 5p minus 7 minus 6, 5p minus 7 equals 0. All right, so it does factor. It worked well. So you have p minus 6 and 5p minus 7. Solving each of these, p minus 6 equals 0. 5p minus 7 equals 0. I'm going to do the magic of just telling what the answers are. Hopefully you can solve them. The answers are going to be 6 and 7/5. All right, so make sure that you can get those as you're working with it. The next one. I'm going to get everything together. I'm going to get that to 0 as well. I like the n squareds. Minus 9n plus 8 equals 0. Now, I see that it's got the plus 8. I know my factors of 8 include 1 and 8, and that's really cool. That's the 9. So this, I could do the completing the square. However, 9 doesn't divide nicely by 2. I'd have to deal with those fractions again. This does factor. So my factors of 8, because it's a 1 and an 8, are 1 and 8, 2 and 4, and that is it. This one is the one I want, and I want them both to be negatives. There's a lot of negatives on this page. All right, so this is going to be n and n equals 0, and then I have minus 1, minus 8. Solving each one of these, yada yada. I know. You get the answers of 1 and 8. All right, this one has just 1c squared. Since it just has the 1c squared, that tells me I can just square root both sides once I get it all by itself. So I'm going to add 14. I have c squared equals 25. I like this one. Square root both sides. plus or minus, don't forget that, C equals plus or minus 5. All right. And then the last row, ooh, one of them's almost done for us. So the last row, we've got a little bit of work for some of these, but it's not terrible. I need to get this, the 18x over to the rest of it so that I see what I have. 5x squared minus 18x minus 8 equals 0. Yet again, this is one that I might use the quadratic formula with. I also could test on the factoring, which is good practice for us. Completing the square isn't going to be so nice because I'd have to get rid of this 5, and 5 doesn't go into everything. So probably if it factors is going to be the easiest. So 5, and easiest is a relative term, times negative 8 is negative 40. This tells me that the signs are going to be different. I'm going to be subtracting factors and hope to get the 18. The factors of 40 are 1 and 40, 2 and 20, 3 doesn't go in there, 4 and 10, and 5 and 8. I'm subtracting. So if I do 2 minus 20, I get the 18. So rewrite it. There's other ways to factor, but I always rewrite to the unfoiling. And then I have 2x, don't forget your x, minus 20x. That replaces this 18. And then minus 8 equals 0. All right, factoring 2 at a time. These two, I can pull out an x. So I have x, 5x plus 2. These two, I can pull out a negative 4. And you'll have minus 4 divided out, 5x minus plus 2. All right, equals 0. Writing this out, I have x minus 4. And then those parentheses are the same, so there's just GCF. 5x plus 2. All said and done, this becomes, remember, you're expected to break it out and solve that. So x equal, my final answers are going to be 4 and negative 2/5. So make sure that you can finish solving that so you get those two correct. All right, the next one looks very similar to the one that we just did. Therefore, I am going to, I'm not going to complete the square, even though I have my x's here. I'm going to subtract the 5 over there. So I'm going to have 7x squared plus 12x plus 5 equals 0. This one, actually, because I've got numbers that I really kind of like, is the one case where I'm going to do the quadratic formula, just so that you can see it. And this goes x equals, because that's the variable I have in the problem, the opposite of b, because this is a, b, c, so negative b, the opposite of b. Opposite of positive 12 is negative 12, plus or minus the square root of 12 squared minus 4 times a, which is 7, times c, which is 5, all over, remember that has to go all the way over here, 2 times the first. So 2 times 7. So simplifying this out, actually simplifying this is equals negative 12 plus or minus the square root of 144. Now, I can multiply in any order that I want, and I like 4 times 5 is 20. 20 times 7 is 140. So 144 minus 140 all over 2 times 7 is 14. And then this gets to negative 12 plus or minus 144 minus 140 is 4 over 14. This is, I'm running out of room, negative 12 plus or minus 2 over 14. grand total answers, what color do I want? I'll take this, is going to be -12 plus 2, which is -10 over 14. And then -12 minus 2 is -14 over 14 is -14 over 14, which then gets me to the solution set of, I have to reduce them. So 2 goes into 10 and 14, so -5 over 7 and -1. All right, this one is mostly done. When we get to the next one, we're mostly done. All I have to do, I have it equal to 0. If it wasn't equal to 0, I'd have a lot of work to do. However, it's equal to 0, so I have m plus 1 equals 0, m plus 2 equals 0, subtract 1, m equals -1, subtract 2, m equals -2. Final answers is -1 and -2. All right, last one. Kind of like the fact that I'm at the end. Now I've got it equal to 0. I've got just r's over here. That tells me I can factor this out by pulling out an r from each of them. So I have r parentheses 5r minus 6 equals 0. I can draw my line through each and solve each one. So r equals 0, 5r minus 6 equals 0, add 6. 5r equals 6, divide by 5. My final answers are going to be 0 and 6/5. And then we can put our answers in here. Yet again, not all of them are going to be used. I did keep, the answers did stay into fractions, which, you know, we can go from there. So I'm not going to put the puzzle together, but we've got all the problems. So let me know if you have questions and keep up the hard work.